So yes, you can see, that's me, Karthick Muruganantham. I'm currently a big data engineer working for JPMorgan Chase. What else? So data points, that's what they say, right? So my data points are I'm passionate about technologies and dance. Yes, you heard it right. Dance is my hobby and passion. I do take lessons back in UK. Mostly Bollywood. So maybe after this session, I could help you with some moves if you're interested. Okay, so yeah, that's enough. Let's talk about my career. So most part of my career, I was a performance engineer. I used to fix and tune applications performance, but lately I developed interest towards big data technologies and mainly Splunk. I'm truly amazed by the fact that data is now changing the world, and I'm sure everyone in this room truly appreciates the value of big data and its contribution towards business. It is inevitable these days, right? So it is there in many fields, starting from banking, finance, cybersecurity, technology, and most importantly, medical science. In recent medical science, if doctors have got access to a patient's health data, he or she could save the patient's life before it becomes a problem, right? Before it becomes a danger to them. It was not possible 5 or 10 years down the line. Now it's possible. That's phenomenal, right? Here, neither I'm a doctor nor a medic to cure a patient's problem, but definitely, I could help or I could fix the health of hundreds and hundreds of servers before it becomes a problem with its data. And that is what we're going to talk about today in Remediation-as-a-Service. Okay? Okay, I don't have anything forward-looking in my statement, in my slide, but they asked me to keep it, so just in case. Okay, ignore it. Okay, so more uptime, more sleep. Sounds cool, right? Who doesn't like it? So in this digital world, everyone wants their application to be up all the time, correct? And of course, all the hardworking technologies deserves a little more sleep, isn't it? So that is the goal of my Remediation-as-a-Service, to give more uptime to the application and more sleep to the engineers. Let's talk about this in detail. Okay, here, so why we need Remediation-as-a-Service? That's a big question here, right? So I would like you to take a quick look at this image and tell me what comes to your mind. So it looks like a survey, right? So it's about poor experience, poor customer experience. So when do you rate application poor? When it responds slowly? When it doesn't give you the required functionality? And most importantly, when it's not available, right? So we know every minute of downtime is detrimental to business. And I don't have to explain the impact of that. So that's that image. And this image might be familiar to you, right? Does it ring a bell? So here I'd like to take a pause and take a little survey. So tell me honestly, how many of you have come across this situation? That is, woke up at the middle of the night to fix system issues or application issues. Come on. 1, 2, 3. Oh my God. I need Splunk to process this data. Seriously. So many, right? This is quite a common problem. If you're an on-call engineer, of course you'll be paged. And when there is an issue, you have to get up and fix it. Whether it's day or night, whether you like it or not, that's part of the responsibility, right? I won't blame it. But what if it's a known issue? What if it's a known issue? Same process, right? You still have to get up and power on your laptop and fix the problem. It doesn't matter whether it's a known issue or unknown issue. So the problem is, in my research, I found a large volume of production incidents as a known and recurring issues, right? So based on Google metrics and our bank internal metrics, on an average, we see 60% of the production issues as known and recurring issues. That's a huge volume we are talking about, right? So my point and my question is, when you have a known response for a known issue, why do we need an engineer to come and fix it? Right? Easy, simple, right? So when you have a known response and a known issue, why do we need somebody to fix it? And remember, when issue happens in an unusual hour, mostly that's how it happens, right? In a night time when you have a night sleep, and that's when it happens. When it happens in an unusual hour and when you have nobody there to fix it, you're looking at a lot of downtime for your application, and that's very bad. And that is why you need remediation as a service to fix simple known issues automatically, and for unknown issues, it could bring up relevant diagnostics. We'll talk about that. So RAS, remediation as a service, fixes simple alerts automatically, and it could easily save up to 1/3 of engineers' time. I didn't put up cost saving because I work for a bank, and due to firm's policy, I'm not supposed to reveal the potential cost savings we have, but you are smart enough to work out 30% cost of your engineer's time, right? I'll let you do the max. Okay. So now we're looking at a day in the life for on-call engineers. Again, does it ring a bell? That was me. That was my life. It was very, very pathetic life, right? So I'll tell you a short story. I'll keep it short. So after a long, tiring and productive day, let's say 12 hours or sometimes 14 hours, I drove back home, had a delicious meal, which my wife cooks. Mostly it would be dosa with a variety of chutneys. For those who don't know dosa, it's an Indian pancake. It tastes yummy. Let's get back to the story. I get drifted into food. Okay, so yes, meal. After the meal, I tucked my kids into bed and watched a little bit of Netflix and before drifting out of bed. Then at 2 a.m., which is not night or not in the morning, you know, right? It's irritating, right? It's annoying. That was my on-call phone ringing at the time. As soon as I heard that, my eyes shoot open and my heart and mind starts racing. And most of the time I was like, what the issue is that? I can't use that word, yeah? So what the issue is that? And on the other side, my wife kicked me out of the bed. So I crawled my way back to the laptop and I powered on the laptop while looking for some coffee. And it took easily up to 15 minutes to get things up and running. Hey, I work for a bank. With all the security and VPN connection, 15 minutes is the best thing I could do to get everything up and running, okay? Don't blame me. So after I get up everything and running, I have to go through all the pages, alert details, and diagnose the problem, and I find, yes, it is a known problem, I know the fix. And I run the fix and implement the fix, right? It could easily take up to 45 minutes. I hope you'll agree, right? Just nod your head or say something, yeah? Yes, I could see that. So easily take up to 45 minutes. Imagine, for a known issue, if it takes up to an hour, how much sleep you will lose for an unknown issue. You never know. So you'll always be looking at the laptop. That's a nightmare. So my point is, why bother when we have systems to do this job for us, right? And that is why, with remediation as a service, you could still go back home, enjoy your delicious meal, tuck your kids into bed, and watch Netflix as much as you can. And most importantly, you could have a peaceful sleep while RAS fixes the problem at the background and keep the system up, right? That's a self-healing we were talking about. So once this fixes the background while I was sleeping, and next morning when I come back to office with fresh mind, then I could triage the problem. I could see, I could do the root cause analysis for the problem. here I would like to clarify a point here. RAS, yes, it will fix the problem. It will fix the known issue, but it will not fix the root cause of the issue. That's up to you to do the triaging. But you can do the triaging while the system's up and running. So that is the benefit of RAS. It not only gives you a good sleep, but also fixes the problem within minutes or sometimes within seconds and keep the uptime of your application high. Okay, so that's what I'm saying there. On-call engineers get more sleep and business gets more time, right? So that's the self-healing we're talking about. Okay, so this is, you might have already started thinking about it. So where RAS might be most useful. So I hope now you got some idea about this, and you might have your own use cases. But I have done some research and I have worked out some very common use cases, and we have implemented some of them in JPMorgan Chase, but it's not limited just for this use case. So once you get the logic, you can implement wherever you think it's applicable. Okay, so restart the application service when the service is down. It's very simple and straightforward, right? So you get to know when the application is down based on your logs, based on your events in your Splunk. So once you sense the log, you take the action. This is data doing action, event-driven remediation. That's what we have been talking about. Okay, so that's one of the use cases we have implemented successfully. And this is restart the application. So instead of application service, it should have been process. It's a mistake. But again, similar thought process. When your process exceeds your memory consumption, you have to restart the process to get up and running. Again, this is not fixing the root cause. This is getting your service back and get it live. Okay, the next one is a cloud use case. You could argue this could be done differently, but yes, this is possible this way also. We have multiple solutions for a single problem, but this is one of the solutions that we could do through data. So you could scale up or down cloud infrastructure based on user volume and user load metrics in Splunk. Again, there are different APIs in cloud to do it, but this is also one of the ways to do it. Next one, this is not a automated response. This is for unknown issues. Okay, when you have known issue, on the other side you'll have unknown issue, right? So this one, when you have a high CPU utilization but you don't know what is causing the issue, this RAS could help bring the relevant diagnostic metrics, a dynamic diagnostic metrics, like hits per second throughput or top process graph. I'll talk about this in detail in the upcoming slide. Next one is a cyber use case. So as soon as you find a breach in your Splunk event, so you have to take some action to the account. The immediate action you would do is block the account. So call the remediation API to block the account as soon as you detect a security breach in your log. Okay, so these are all the use cases that we worked out, and we implemented some of them, but I'll leave you to work out your own use case. Hope it's okay so far. Could we take it later? Yeah. Thank you. Now, so this is the most important slide, how it works, how this concept works. So again, due to my firm's policy, I'm not allowed to put our internal architecture. So this is a conceptual framework for you. So this part, everyone knows, I guess everyone knows this, that is getting the data into Splunk, right? So everybody knows it. So what RAS does it, Remediation-as-a-Service does it, it builds the bridge between Splunk, that is monitoring tool, and an automation tool. Okay, so automation tool, you could take any automation tool. So some of the industry standard automation tools are Ansible, Puppet, Chefbook, and today morning we talked about Phantom, right? So to do event-driven automation. So you could pick any one of those tools. So RAS does it bridges the gap, builds the bridge between the monitoring and automation tool. So once you have your data in Splunk and the known response in one of the automation tools, in any of the industry standard automation tools, what you have to do is package this solution, package the alert and the known response into a simple app. You could use Splunk Phantom or build your own Splunk app. I would take a KV Store app, Splunk KV Store app, and map the alert, that is a problem, with its known response, response API. For security purpose, you could add access controls along with it. So you take 3 parameters, that is alert, which senses your problem, the response for the problem, that is your automation API. The third thing is your access grant. Once you have these 3 parameters, store it in KV Store, okay? So as soon as the alert kicks off, in the background, you construct a dynamic API. That is, the alert should find its appropriate response along with its access control and initiate the call. So this call will run the playbook on the impacted host and fixes the problem for you. Right? Simple it sounds. I'm sure as soon as you start exploring about the automation tool, I'm sure some of you would have already done it. But if you build this bridge, all this self-healing works fine, and then you get out of remediation as a service. Right? So that is the first solution we're talking about. This is for known issues. So when you know a response for an issue, you map it, and then next time when the alert goes off, your response gets called and fixes the problem for you in minutes or seconds. And the next solution I have here is for unknown problems, right? Of course, we can't resolve every problem automatically. There will be some unknown issues. So what we're going to do about it? So if a new error or log comes up, of course, we can't fix it automatically because we don't know what's the response. But we could try to bring some relevant diagnostics. For example, I don't know the issue, I don't know the error, but I see some abnormal behavior in my servers. Let's say CPU spikes are out of memory. It's a quite common problem, right? So what would an engineer do when issues like that happen? So when I was a performance engineer, as soon as I see CPU spike, the first thing I go and see is stop process. I'll see which process is consuming CPU. And what is my throughput? What's my hits per second? That's quite common, right? So if you take any problem, you will see 4 or 5 graphs. That's what engineer would do. So if you template that in a dashboard, a CPU problem or a memory problem, so all you need is 3 dynamic parameters, right? So you would want to know the start time of the problem and end time of the problem, and third thing is the impacted host, right? So these 3 are the dynamic parameters. So once you have the dashboard set up for CPU or low memory with the relevant graphs, if you pass the start timestamp and end timestamp along with the impacted host, you will be seeing a dynamic dashboard which dynamic metrics during the problematic window. And this, we pretty much saw a glimpse of it in today's morning keynotes. Tim was talking about indulge design, where they brought up a dynamic dashboard. As soon as they hit the link, it brings the dashboard of the problematic server. So we don't want to miss that moment. We don't want to miss the moment when the problem happened. And that is what this is going to give. Because imagine an on-call engineer comes 8 hours after the problem, and then you read the problem, and then you have to look through all the logs. Even if it is a centralized log, you have to look at the timestamp. You spend time there, right? But this one will directly take you to the incident time and show you what had happened before and after. And this will help to reduce the mean time to repair the problem, right? And that's very, very important when you're dealing with production issues. I hope everyone appreciates that, right? So for unknown issue, you should have a dynamic dashboard by passing the 3 arguments, start time, end time of the problem, and the impacted host to the dashboard, and get this dashboard link page to our on-call engineer. As soon as he comes to the office, the first thing he hits is this link, and then he sees the problem. And that is the 2 solution I have worked out through a RAS concept. For known issue, You know the response, you go and fix it. For unknown issue, try to bring relevant diagnostics metrics as possible to reduce your mean time to repair the problem. Okay, so far? Right. So that's a conceptual framework. Now we are talking about numbers. So everyone likes number, I like number, and business needs number. So this is a sample result we have achieved in few applications in JPMorgan. We are working out a firm-wide release of this solution. So far we have seen greater than 90% of the known incidents reduced, and greater than 99% application availability observed, and 1/3 of known issues resolved. So this is taken from JPMorgan metrics. So beyond any numbers, right, the most important thing you could achieve with this is you will be improving and enriching the customers' and employees' experience, which is very vital these days. Every bank and every big companies are trying to do that. So this will help you to improve your employee experience. You give your on-call engineer more sleep, and you are allowing him to concentrate on more useful tasks rather than a known repetitive task, and keep the uptime of the application high. Right? So these are sample results, what we're talking about. The future for JPMC and RAS, as I told you, we are looking for a firm-wide rollout. And what you will accomplish with RAS, I forgot. Let me see. Okay. So integrate with Splunk ITSI. So based on all what I've told you, you would have already worked out. This could very well be fitted under ITSI because of its benefits and purpose. If we integrate this solution with ITSI, it would help us to broaden the scope of RAS to do a lot of use cases. That's our future roadmap. And second thing, so I talked about fixing a known issue. That is, once the issue happened, you run the playbook and fixes the problem. What if we apply machine learning and implement predictive analysis and fix the problem before the issue happens? So this is more preventive approach. You are fixing the problem before the log even appears in your Splunk monitoring tool or any monitoring tool. So that is the future. So we are working with Splunkers to collaborate and innovate this solution. So I hope we'll do more things with this. And finally, key takeaways. What I would like you to take away from this session is RAS is a powerful part of modern DevOps, as you could have worked out from this. And it also helped to transform the way your IT operates, okay? Because you're going to reduce a lot of time in fixing the problem. You're going to save time for your engineers. That's the modern DevOps way of doing it. And second thing is, Doug and Tim kept saying this morning about data doing action. And this is data doing action. This is event-driven remediation or data-driven remediation. Okay, so here we showed how to orchestrate the data and automation. Yes, Phantom does it to a level. The same concept we implemented without Phantom. So whichever works best for you, try and implement it, and you get to make a lot of savings. And finally, sleep. Remember that. So that's, if you take that one takeaway from the session, I'll be more than happy. So your on-call engineers, including me, deserve a lot of sleep or extra bit of sleep. And with RAS, it's definitely possible. With that note, I would love to take a couple of questions from you. Shoot. Yeah. Okay, that's an interesting question. I was expecting that question and voluntarily hidden that information. Just for everyone's understanding, his question is, sorry, your good name, please? Balaji's good question is, how do we keep track of the issue? Okay, so RAS goes and fixes in the background, fine, good. But as an on-call engineer, as a manager, you should know what's happening in your system, right? So how do you keep track of the issue? Very good question. So as part of the fix, it does two things. As I told you, it won't fix the root cause. It fixes only the known issue. So while it does it, or after it does it, this could automatically create a HPSM ticket. By using a webhook functionality in Splunk, you could automatically create a HPSM or ServiceNow ticket and get it assigned to the on-call engineer, so that while once you get the fix done, and while the system is up and running, and when you come back to work, you will still have your ITSM ticket, or HPSM or ServiceNow ticket for you to triage it. So that is the way you keep track of the events and incidents. Yeah? Is it okay? Anybody else? Yes?
What can you run, or what are the actions that you can run? Is it limited to only scripting, or is it have some options that
That's another interesting question. That is, if I understand that correctly, so his question is, what kind of run books or playbooks you can run, and what are the limitations, correct? Okay, so there are no limitations, to be honest. It's up to your automation skills and what you want to do. It's all about. Let's take a simple issue, right? So if application is down, what would an engineer do? He logs onto the box, and then he run a command to bring the service up. Okay, let's take 2 or 3 commands is what he would do. And you create that in a playbook nicely. Ansible or Chef or Puppet allows you to do it. Okay, this could be elongated to simple, medium, and complex use cases. As long as it is known and simple and straightforward use cases, you could do anything with it. There is no limitation. Good question, though. Thanks. Any other questions? Yes.
Can you give us more details about what this Splunk app bridge is? Is it a custom script? Is it something you can?
Okay, cool. Okay, so his question is about the app. So I mentioned about a KV Store app where we map the alert and response. So he wants to know more detail about it. Yes, it is we created a custom app. So we didn't know about Phantom that time. So we created a simple KV Store app in Splunk where it will allow you to take input parameters. That is here, the alert is the first input to sense the problem. Second input is obviously the response. So you are mapping alert and the known response. And in our bank, so we want to control the access because we don't want anybody to execute any script in any servers. So we want to access, we want to do a controlled way of executing it. So we took the access parameter as well. So 3 parameter values. So once you submit, that value will get stored in Splunk KV Store. And when you do an input lookup, you could read those 3 values. Let's say alert service is down, has kicked off. And internally, we would have mapped a restart script, Ansible restart script. And team A is only allowed to do that. So all these 3 parameters will be stored in KV Store. And when you run an input lookup, it will read the 3 values and pass it on to your internal Python script, that is alert action script. And it will construct a dynamic API and shoot the call to the platform and run the playbook on the host. Okay, so the simple answer is yes, custom app built. Yes. Okay, so, interesting question. So his question is, do we do the logic in the playbook, or do we do the logic elsewhere, especially in Splunk, right? Okay. We do logic in both places. Again, there is an interesting and tricky point over there. I was expecting somebody would ask. In a correct event-driven activities, it is fine. It is very good. So when you find the right event, you call a right action. What if there is a false event, right? If something falsely came up, right? So you keep triggering remediation, which is not good, right? It's going to hit your server. It's a problem for you, right? So you have to apply a logic there. So in Splunk, you have a threshold or suppression mechanism to control how many times you call an alert based on some conditions. Okay, so I do it 3 times, do a 3 retries. So that is the Splunk logic. And in the script, yes, you try once, a second time, a third time. If it doesn't work, there is something seriously wrong there. So after the third time, don't try again. Send an escalation email to on-call engineer. Now wake up that guy. He should not sleep now. Okay, that is what you should do. So both places we apply the logic, right? So in Splunk, use the threshold and suppression mechanism to limit your action calls. On your backend script, yes, try a couple of times, or how many other times you want to do, and after a certain point, escalate and do a certain action. Don't keep doing it. Automation will be dangerous if you do it infinitely. Anybody else? All good? Really? Okay, if that's the case, thank you so much. Thanks for listening to me patiently. Yeah. And thanks for the great questions. Thank you all.